Hi, today we are looking at dividing polynomials by binomials. So we'll look at two different ways to do so. So one is utilizing long division, while the other is utilizing synthetic division. So like I said, two main strategies. One is long division, which we'll review with some questions you may have seen in the past before going into it with polynomials, and then we'll go into how to do synthetic division and the restrictions on doing division with synthetic division. So, for example, use long division to solve. So for many of you, it may have been quite a while since you've done long division, so we'll go through it with this question here. So we've got 2,748 divided by 13. So setting up our equation, it should look like this. And then if you remember with long division, we take what's out front and we see how it fits in working from left to right. So 13 cannot go into 2, so then I'll move over to next digit. So 13 can go into 27 2 times. So then I'll go 2 times 13, which gives me 26. We then subtract that. So 27 minus 26 is 1. We bring down the next term. Now 13 can go into 14 once, so we'll put a 1 up here. Then we'll go 1 times 13, which is 13. We're subtracting those. So 14 minus 13 is 1. We bring down this 8. 13 can go into 18 one time. Subtracting that gives us 5. Now we don't have anything left to bring down, so this 5 becomes our remainder. So now that we've gone over this question from the past, we will look at what happens when we do it when we have a polynomial in here and a binomial here. So we have this example, x squared plus 3x plus 6 divided by x minus 1. So we'll set it up the same way. So we have x minus 1 out here, and then x squared plus 3x plus 6. Now with division of polynomials by binomials, the key thing is we're not too worried about this value after our variable. Instead, we're just focused on this in front. We're looking at how many times this x can go into each term. Now, long division is nice because we don't have any restrictions on what we can divide by here. So if we wanted, we could have a number in front of this x, we could have an exponent on this. We could do either one with long division. So x goes into x squared x times. So what we'll then do is go x times x is x squared. X times -1 is negative x. So we are subtracting this. So x squared minus x squared, those just cancel out. Then we have 3x minus negative x, so that's 4x. And then we'll bring down this next term. Now x goes into 4x 4 times, so we've got plus 4. So we'll have 4 times x is 4x. 4 times -1 gives us -4. We're subtracting that. So these 4x's will cancel. Then we've got 6 minus -4, so that's the same as 6 plus 4, so that's 10. We have nothing left to bring down, so this is our remainder. So we've got x plus 4, remainder 10. So our quotient would be x plus 4 with a remainder of 10. Okay, so we'll do another one, this one with a polynomial that is 1 degree larger, so degree 3. So we have 3x cubed plus 4x squared minus 2x plus 4 divided by x minus 2. So setting this up, we've got x minus 2 here. And then in here we have 3x cubed plus 4x squared minus 2x plus 4. Now x goes into 3x cubed, 3x squared times. So 3x squared times x is 3x cubed. 3x squared times -2 is -6x squared. We're subtracting this line. So 3x cubed and 3x cubed cancel out. Then we have 4x squared minus -6x squared. So that's going to give us 10x squared. Bring down our next term of -2x. X goes into 10x squared 10x times. So that's going to be plus 10x. 10x times x is 10x squared. 10x times -2 is -20x. And we are subtracting that. So our 10x squareds are going to cancel out, and -2x minus -20x is 18x. We then bring down this last term. So we have plus 4. X goes into 18x 18 times. So 18 times x is 18x. 18 times -2 is -36. We're subtracting this. So 18x minus 18x, those are going to cancel out. Then 4 minus -36, that's 4 plus 36 essentially. So we've got 40. So our quotient is 3x squared plus 10x plus 18. And then we have a remainder of 40. Okay, so we'll do one last one before looking at division statements and then going into synthetic division. So we've got 4x cubed plus 3x plus 20 divided by x plus 4. Now this question has a bit of a trick to it because essentially we're jumping from x cubed down to x, which is technically to the power 1. So when we enter in our division, we want to include our x squared term, so we have appropriate spacing. So we've got 4x cubed, and then because we're missing our x squared term, we'll just put plus 0x squared. Then we'll put plus 3x plus 20. Now, the other thing is we're always going to want to have our exponents in descending order. Okay, so x goes into 4x cubed, 4x squared times. 4x squared times x is 4x cubed. 4x squared times 4 is 16x squared. 4x cubed minus 4x cubed, those cancel out. 0 minus 16x squared would be -16x squared. We bring down our next term, which is 3x. So x goes in -16x squared, -16x times. So -16x times x is -16x squared. -16x times 4 is -64x. We're subtracting these. So these cancel out, and we've got 3x minus -64x, that's 67x. We bring down our 20. X goes into 67x 67 times. So 67 times x is 67x. 67 times 4 is 268. Now we're subtracting this, so that's going to cancel that. And 20 minus 268 is -248. So this one has a quotient of 4x squared minus 16x plus 67 with a remainder of -248. So next we'll look at division statements, which is a way of writing out our answer. So a division statement takes the form P of x equals x minus a times q of x plus r, where this P of x is our original polynomial. X minus a is what we're dividing by. Q of x is the quotient that we're getting, and then we have plus our remainder. Essentially, we have what we're dividing by times our quotient plus our remainder, which should give us our original polynomial. So we'll go back and write the division statement of that question we just did. So we know that our division statement takes the form of P of X equals X minus A times our quotient of X plus our remainder. So our original polynomial was 4x cubed plus 3x plus 20. And that's going to equal what we divide by, so x plus 4 times the quotient we got, which is 4x squared minus 16x plus 67. And then we have plus our remainder. Now, in this case, our remainder is negative. So if we add a negative number, that's just going to be the same as subtracting. So we have minus 248. Okay, next we will look at synthetic division. Now, synthetic division is what I use normally if I have a choice between long division and synthetic division. There is restrictions on when we can use it, but it is much faster than long division. So it can be used to divide a polynomial by a binomial of the form x minus a. So you'll notice that it is purely x minus a. So we don't have a number in front of our x. We also don't have an exponent on that x. So it's not as versatile as long division, but it can be very quick. So for synthetic division, when we set it up, we remove our variables and only use our coefficients. So we'll do this example and go through the various steps. So we want to divide x squared plus 2x plus 5 by x minus 1. Now, when we're dividing, that's of the form x minus a. So technically, if we've got x minus 1, our a value would be positive 1. So our first step is to write our a value on the left here. And then all of our coefficients on the right. So x squared would technically have a coefficient of 1. 2x has a coefficient of 2. And then we have our constant term of 5. So that's our first step. Now I'm going to write these out with several different brackets, several different synthetic division brackets to show the steps. But when I do it in a later example, I'll just do it all in one. So I'm just going to copy out what I had here. So I have 1, 1, 2, 5. Now this step here, we're bringing down our first coefficient. So that's 1. We then multiply it by our a value, which is here. So we go times 1, and then that value goes here. 1 times 1 is 1. Okay, so we're on to the next step. So once again, copy out what I have here. So I have 1, 1, 2, 5. I brought down for 1 here. I've already multiplied this by 1, which gives me 1 here. Our next step is to add these two that are in the same column. So 2 plus 1 is 3. And then we multiply it by this a value again. So times 1, which gives us 3 here. And then we essentially continue doing this until we have nothing left to bring down, which it looks like we will be at now. So we have for 1, 1, 2, 5. We brought down for 1, multiplied it by 1, which gave us 1. Adding these gave us 3. Multiplying this by 1 gave us 3. Now we're on to, once again, adding the column. So we have 8. Now, at this point, we need to go from these into our actual answer. So there's two different ways to do it. One is working left to right, the other right to left. So this last column is always our remainder. So if I'm working right to left, I have my remainder is 8. My next term this way is my constant term. My next term here is x. If I had another term here, it'd be x squared, then x cubed. The other way is we can work from left to right. We know that this first term is always going to be 1 degree less than what we started with. So because we start with a degree 2, we know this first term is going to be a degree 1. Okay, so we will try another example and write our division statement. Now this one has a bit of a trick to it. You'll notice that we don't have an x cubed term. So we need to make sure we account for that. So technically we've got 0x cubed. So we'll set up our synthetic division. So in this case, because we take the form of x minus a, our a is technically positive 3. So we'll write 3 here. Then we'll take these coefficients. So we've got -4, 0, 2, -1, -3. The first term comes straight down. So -4, 3 times -4 is -12. Add these, that gives us -12. Times 3 gives us -36. Add these, that gives us -34. Times 3 gives us -102. Adding those gives us -103. Multiplying by 3 gives us -309. Adding those gives us -312. So if I wanted to say work from this way to this way, because this is x to the power 4, we know this is our x cubed. So we've got -4x cubed minus 12x squared minus 34x minus 103 with a remainder of -312. Now, if we're wanting to write our division statement, remember that is our polynomial. So -4x to 4 plus 2x squared minus x minus 3 is equal to what we're dividing by. So x minus 3 times our quotient, which was -4x cubed minus 12x squared minus 34x minus 103, and then plus our remainder. In this case, it's a negative remainder, so minus 312.